Hello and welcome back. Today we are going to be discussing independent probability. Now please do keep in mind that this will be different from our more advanced skills of what we would call a not probability problem and an or probability problem. We're not going to get to those quite yet. Today we'll just take a look at the basics. What is probability? Probability describes how likely it is that something is going to happen. Now, we may not have quantified this quite before, but this is something that we do every day. Whether we flip a coin or we wonder whether we'll need to take an umbrella. Now, to make probability less vague, we typically express this in odds of something happening, which we can then convert to percents. So for example, if we're flipping that coin, we have two equal results. Heads would be 50% and tails would be 50% as well. But if the weather report says that there's a 90% chance of rain, we'll probably want to take out that umbrella. Now we can see probability expressed as a number between 0 to 1. With 0 meaning that there is 0% chance it will happen, and 1 meaning it is 100% likely to occur. For example, a 0 would be the chance of seeing a flying elephant tomorrow morning. The probability of this occurring will be 0%. Elephants just simply cannot fly. However, a 1 would be waking up tomorrow to see the sun rise. This is a 100% chance, as the sun rises and sets every single day. Now, when it comes to tested questions on our math exams, we don't want to be distracted by the objects in the question or the method with which they're being assessed. For example, whether it's 20% or 0.2, whether we're dealing with marbles, cards, coins, food, anything. A probability question essentially will boil down to finding a specific number of possibilities out of the total number of possibilities. Let's go ahead and bring in our formula. This is the probability formula. This is the basic formula for probability. The probability will be the number of what we want divided by the total number. Let's take a look at an example. If a bag of 11 total gumballs has 6 red gumballs, then the probability of randomly selecting a red gumball is, here we can look at our number of what we want here. That will be 6 divided by the total number will be 11. The probability of randomly selecting a red gumball in this case will be 6/11. Which also can be written as 0.54 as we divide 6 by 11. Which also as a percent can be expressed as 54%, as percent means out of 100. We multiply 0.54 by 100 to get us to 54%. The probability of randomly selecting this red gumball, when there are 6 out of a possible 11 total gumballs, can be written mathematically. There's a 6/11 chance, there's a 0.54 or 54% chance of randomly selecting this red gumball. Now let's take a look at an example problem. We'll bring in our formula once again along with the problem. A gumball is randomly selected from a jar that contains 5 blue gumballs, 15 red gumballs, and 30 yellow gumballs. What is the probability that the randomly selected gumball is red? Here the question is asking for probability. So we'll refer to our probability formula, the number of what we want over the total number. Now here the question is asking for the probability that a randomly selected gumball will be red. So the number we want will be the number of red gumballs. In this case it's 15. And the total number we will need to add. We have 5 blue gumballs, 15 red gumballs, and 30 yellow gumballs. Let's add our gumballs together. 5 plus 15 plus 30 will give us a total of 50 gumballs. Therefore, the probability will be 15 divided by 50. Let's notice that this is not a choice in our answer choices, so we will need to reduce the fraction. We'll notice that both the numerator and the denominator are multiples of 5. Let's divide out both the numerator and denominator by 5. 15 divided by 5 is 3. 50 divided by 5 is 10. Giving us a fraction that we do see in the answer choice. Answer choice B is the correct answer. Here we can use the probability formula the number of what we want divided by the total number to find the probability of randomly selecting a red gumball when there are 15 gumballs out of a possible 50. Let's not forget that we sometimes need to add together each part to get our total. And this will be independent probability.